Okay, see, again, they give the dy dx. Okay, step 1, always mark out where the dy dx is equals to 0, not the turning point, it's 0 because we are talking about this is the dy dx. So where is dy dx equals 0? It's when x is equals to 0 and when x is equals to 4. Okay, state the values of the x coordinate of the stationary point and the nature. Same thing, when, so A, when dy dx equals to 0, what are the two values? First, x equals to 0. The other one is x equals to 4. Yeah. Do a first derivative table. Now, as time goes by, if you feel that you're comfortable not doing the first derivative table, it's okay. It's not a requirement. It's not a requirement to do it, but it definitely will help you to understand. Okay, dy dx is 0, flat. On the left side of 0, dy dx is positive or negative? Positive, even though it's going downwards. Yeah. Then on the right side, also positive because it's just in the positive region. So it's a up, flat, up. So x equals to 0 is a point of inflection. Easy already. After you do it 2 times, you'll find that it's easy already. Okay? Same thing. Even now, like I say, can I don't draw the first derivative table? Can. So on the left side, this guy, you just write it positive, okay? And then because this dy dx equals 0, on the right side of 4, it is negative. So it's positive, flat, negative. Yeah, x equals to 4 is a maximum point. Okay, but I find it there's a very big gap here lah. That means there's no working to show it, So that's why I say if you draw the first derivative table, it really tells the examiner how you understand the first derivative can be used to finding the dy dx. Okay. So now you all know how to find the. This one I will extend it a little bit more. Okay. So let's do the d2y dx square graph first. That means assume that d2y dx squared is equals to 0 when. So why do you think they tell you this? d2y dx squared equals to 0 means the turning point of your dy dx. So let's paradigm shift. So let's say this guy is your y, this guy is your dy dx. Okay, they tell you that equals to 0 and then equals to 3. Okay, so you mark out these 2 points that it will intersect the y-axis. Okay, let me in this case let me draw it like proportionately. That means over here, directly below. Okay, which means can you see this is a turning point? Yeah. If I bring it down all the way here, it means that dy dx must be equal to 0 at this point. Okay, turning point means there must be a intersection at this point. Okay, now on the left side of 0, then now I look at the gradient of him. The gradient of him is positive or negative? Negative. Then very negative, right? Very steep in a negative way, right? Negative become gentle. So means starts from a very low point and then you will hit here. This is the 0. Okay? Then after it passes 0, the gradient is positive or negative? Positive. Positive from gentle to steep or steep to gentle? Gentle to steep first, then after that back to gentle again. Can see? Gentle, steep,
Yeah.
gentle, then 0. So that means it will go gentle, go to very steep, means it will increase in value. Then after that it will start to decrease in value again. Okay, then the last part, don't even need me to tell you, then you can just draw this, go down. Okay, so this is x. When we label them, this guy we do not label as dy dx, we label as d2y dx squared. Okay, let me twist it a little bit more. Okay, let me twist it a little bit more. Now this guy is your dy dx. Can we draw the y against x graph or not? Can we draw the y against x graph or not? Okay, so first thing, remember the most important thing is we know that we already found the nature already. Point of inflection and a maximum point. Okay, so how will this graph look like? Point of inflection, and then it must follow. So this guy is a down flat upwards. Okay, at 0 is a point of inflection. So how does it look like? It will start from here, go to here, okay, and then go upwards. All right, and then it will turn when x is equals to 4. So you just put a 4 here. Yeah. So this is your y equals to fx curve. Okay, most of the time they will start at dy dx lah, and then ask you to draw d2y dx squared, or ask you to draw y equals to fx. Is it possible that they start with y equals to fx and they ask you to draw dy dx? It's also possible. Okay, so the important thing about this, if you get this kind of question, the dy dx graph or the d2y dx squared graph, okay, it is not possible to find out what is fx. They will never ask you to find out what is fx. Use the information from the graph to do a sketch of your curve. Okay, by understanding when is it dy dx equals to 0 and what is the value of the dy dx. If you know how to convert any graph to your first derivative test, half a battle is won already. Okay, because after you convert it to your first derivative test, you already know how your graph will look like when it's a point of inflection. And why is this point of inflection this way and not the other way? Because here already tell you that the point of inflection is this way.